Alright, so just one is a presentation for our group, and just one is a group member and their student ID. Our presentation aims to demonstrate how AWS core services include the financial data storage and processing, and explain the layer security model implemented in AWS, and also show how network protection is achieved through segmentation and routing, and highlight IAM principles for access control and compliance, and also emphasize the integration of all layers into unified secure architecture. And this one is for my part, network security. The topic I'm going to cover is virtual private cloud, subnets, internet gateway, root tables, NAT gateways, security groups, network ACL, flow logs, and CloudFront. Alright, so for my part, I create my VPC, which is this one, and I name it assignment to my name and VPC. So I have created with the IP range of 10.0.0.0/16. So this one is the VPC is as a private and isolated environment where I can manage all network components, including the subnet, routing, and firewall. So I divide the subnet part into 6 subnets: private A, private B, private app A, private app B, and private database A, private database B, and public subnet hosts the internet facing resources like the load balancer, while the private subnets host the back-end services such as EC2 and RDS. So the reason why I split into 2 available zone is, as you can see in here, yeah, I divide into 2 available zone. So the reason why I do it, because like it will have like has a high availability and better fault tolerance. Alright, so the next one is internet gateway. So I create the internet gateway and I assign it into the assignment to VPC. Next part is the root tables. So I configure the root tables to control the traffic flow. The first one is a public root table. So it's gonna go to the internet via the internet gateway, which is you can see from here. The next one is a private app root table. This one is will go through the NAT gateway, which is like I create 2 different NAT for 2 different private app root table. And the last one, we will talk about how to create the NAT gateway later. And the last one is a private database root table. So this one is not connect to any internet. Not connect to any internet. To isolate the database from external network. Alright, so next part is a NAT gateway, but we need to create the elastic IP address first. So I create 2, and after that I create another 2 NAT gateway, and I assign the IP, the elastic IP into these 2, and I assign it back into the private app root map A and private app root map root table B. Alright, for the next part is security groups. I have created 3 security group, which is ALB, the app, and the RDS. So for the security group, ALB is allow the HTTPs from the internet, and the security group app is allow the HTTPS from the security group ALB, and allow the MySQL from RDS. And the last one is security group RDS is only allow the MySQL from the security group app. So basically, just one is a flow map of the security group. So just ABL only allow the HTTPS from internet, while the app server, which is SG app, allow the HTTPS only from the SG ALB, and the database only allow the MySQL from the app server, but the app server can go to the VPC endpoints like the AWS services via just port. For the next one is a network ACL. I have created three network ACL in here, which is the one for the public network ACL, and I add the rules in the inbound and outbound, and I link it to the public A and public B. Same thing with a private app. I also add the rules in the inbound and the outbound and link it into the private app. The last one is the same thing with private database, and same thing with two previous part is also linked to the private app, the private database A and private database B. And I also create the VPC flow logs. I enable just to record all the network traffic in my VPC, and the log was sent to the cloud watch for monitoring and troubleshooting connectivity and security issue. Just improve overall visibility and auditing of the network. And the last part is I create the cloud front to enhance the system performance and security. As a global content delivery network, CloudFront caches the content at edge locations, just reduce latency for user worldwide. By connecting to the application load balancer, the system becomes faster, more secure, and high available.
Okay, so my name is Vũ Trường, and my responsibility in this project is a security in AWS component. Security in the cloud not just about protecting the server, it's about protecting data, users, and operations through visibility and control. AWS provide built-in service that make this possible without third-party tools. So first of all, AWS CloudTrail is the foundation of accountability in the cloud. It records every API call made in the account, who performed the actions, when, and from where. This audit trail supports compliance frameworks like PCI, TLS, and ensures transparency across all teams. Next up, we got the CloudWatch, which complements CloudTrail by providing continuous observations of performance and security metrics. It also collects logs and trigger alerts whenever something unusual happens. So for example, sudden error spikes or repeated access failures. So next up, we got the Group8888 as an intelligence layer. Instead of waiting for an administrator to notice something, it used machine learning models and AWS threat intelligence feeds to identify potential attacks such as credential compromise or data exposure. So next up, we got AWS WAF and Shield Standard. So they protect the front end of our applications. WAF filters malicious web requests like the SQL injection or cross-site scripting, while Shield Standard automatically mitigates DDoS traffic at the network layer. So together, these services from the backbone of our security framework, each one addressing a different layer of defense. So next up. So in this slide, we got AWS service. So there's 4 main in total. So CloudTrail, first of all, CloudTrail ensure that every event in the cloud is logged. This gives us complete visibility and support auditing, essential for detecting insider misuse or verifying regulatory compliance. Moving upward, we got the CloudWatch, which acts like the heartbeat monitor of the system. It gathers logs from the applications and infrastructure and automatically triggers alarms when metrics exceed defined threshold. Next up, we got the Guard2D layer, which brings proactive protections. So it does not just react to errors, it analyzes network flows and uses behavior continuously to find anomalies and could indicate compromised resources. So next we got WAF and Shield Standard. So it provides real-time defense against internet-facing attacks. So they stop malicious traffic before it reaches our applications and keeping service online even during heavy load or attack scenarios. So all these layers operate automatically, reducing manual effort while increasing overall resilience. That's what makes AWS security both scalable and trustworthy for the financial workloads. So since I have very limited permission to perform such actions, so I will be show you how to perform all the procedures on the CloudTrail and CloudWatch. So next up we got the CloudTrail right here, so we can name it like any name we like a math. Let's name it one events 4, and we click on create new S3 buckets and disable the log file, and let's click up next. So click on these all the boxes, and for the API activity we click on read and write only, and yes, resource we can click on S3 and click on create trails. Yes, and we have successfully created the CloudTrail. Next up we got the CloudWatch. Just click on IAM. So roles, create roles, ID service. Use case we click on EC2. Next, search for CloudWatch agent server policy. Alright, so role name, let's say yes, it's CloudWatch agent server, and when create roles we can directly launch the CloudWatch service.
Hello everyone, my name is Hong Yuma, student ID 2508810 from Group 8888. In this part of the project, I will demonstrate the implementation of Identity and Access Management, or IAM, in our AWS Financial Service Cloud architecture. Because this is a student AWS academic account, some operations such as saving custom policies, attaching admin level permissions, or configuring MFA cannot be fully completed. For those steps, I will demonstrate the interface and explain the actual process used in real AWS environment. First, IAM users represent individual identities within an AWS account. Instead of sharing one root account, each developer or operator should have their own IAM user. Here, I navigate to IAM and the users, add user, create user, and give the user a name. Next, I enter a sample username such as DEV user01, enable console access, and set an initial password. And this approach provides unique credentials for each person, enabling accountability and more granular access control. And the next step, we use the next part is about the groups. Next, we use groups to manage permission at scale in IAM user groups. And create a group called DEV read only. DEV read only. And attach the AWS manager policy read only access. Then I can add DEV user01 to this group. Add here, all permissions are now applied through the group, which simplifies permission management and keep access consistent across users. And the next step is about the roles. Roles different from users. They are not tied to specific individuals, but are temporary identities that AWS service or external entities can assume. For example, an EC2 instance can assume a role to access an S3 bucket without storing permanent access keys. Here I navigate to IAM and the roles, IAM and the roles. Create roles, select AWS service and the EC2. And attach a list of privileged S3 read policy. In real environments, this allows EC2 incidents to access S3 security without manual key management. And the next step is about the policies. Policies are the core of IAM. They define exactly what actions are allowed or denied and on which resources. Because student account cannot save custom policies, I will demonstrate this using the JSON policy editor. Each policy includes a version and one or more statement objects, specify the effect, action, and results. Here is an example. List the privilege policy that allows read-only access to a single S3 bucket, and I will paste the command line into here. And the policy, with policy organization, get it here. And here. Yeah, this policy allows the get object action only on the object within the example bucket in a real AWS environment. I will click next, review the policy, give a name, save it, and then attach it to a new to a user, group, or role. And finally, I can navigate to IAM user, select the user we have already created, permissions, add permissions to show where this policy would be attached in a real deployment. Even though I cannot finalize this step, demonstrate the intent workflow. And the next step is about the MFA and the credential security. In real AWS environment, multi-factor authentication MFA is essential to secure privileged accounts. Normally, I would go to IAM users and selected a privileged user and then open the security credentials tab. In this tab, there is a button assign MFA device, which allows us to enable MFA. Since I cannot create users in the student account, this session is not visible. However, this is the standard MFA enable process in production AWS environment. And the next part is about auditing and access analyzer. IAM also integrates with AWS auditing tools. Access analyzer detects public or cross account sharing, something like this. And the credential report summarizes the security posture of all IAM users, such as password usage and key rotation. Credential report here. And the last is CloudTrail, logs all administrative actions for incident response and compliance. This tool will give administrators visibility and help meet regulatory requirements. In the end, the last part is finally IAM ties everything together in our financial service cloud architecture. Developers receive read only access through groups. Operations teams get backup and restoration permissions. EC2 and the LAMP BDA use rules, not hard code keys, for service to service access. All actions are logged and monitored through CloudTrail and Access Analyzer. This layer model aligns with list privilege, zero trust, and compliance frameworks such as ISO 27001 and PCI DSS. In the end, that concludes my demonstration of the identity and the access management implementation for our project. Thank you for watching.
Hi, I'm Yihan Wang. In this video, I'm demonstrating my part of the project, implementing storage and database service on AWS, including S3, Glacier, DynamoDB, and RDS. This is the S3 bucket I create for storing transaction report and the log file. protect all by default enable grid. As you can see, enable service-side encryption using AWS KMS to protect all upload data. I also turn on version, which help to recall version of in case assigned deletion. To ensure data price, I block all public access, and access control is managed through IAM policy only. And next. Finally, I plan to use Amazon S3 Galaxy Vault to long-time data retrieve. To create a vault, it's not. Go back to my bucket. Management to create left rules. Colored version and the to solve this, I use S3 left rules in which automatic transorder or less frequent access data into the Galaxy flexible return storage after state of then in the case the 30 days. Okay, next. And to create. Next, I move Amazon DynaDB, which was planned to handle real-time financial transaction date. The name. String. I try to create a transaction, but you can see the operation failed because my IAM role doesn't have permission to perform the dynamic create table action. This is common limitation in student or lab environment. Here on Dynamics console, we can see the table list is empty. This is where my table would normally appear to store transaction IDs, timestamp, and user active date. And this is my assessment tool. Okay, next. RDS to create my SQL. Here is my Amazon RDS MySQL instance configured with Motive as developed. This ensures high available and automatic fail in case of downtime. I also enable SSLT as ensure for secure line between the application and database. Automatic forgive Dell to grab data durable because I don't have the permission. I'm able to create it. Yeah, it's not. Okay, next. The CloudWatch. Finally, I use Amazon CloudWatch to demonstrate monitoring and logging. Although no logging group for current create, this is a central service from S3, RDS, and dynamically to help monitor and detect anomaly. It's essential for maintaining visible, complaints, and system reliable in cloud environment. Through this project, I learned that cloud storage security is not only about where we store data, but how we manage its reliable through the encryption, version, and recall storages. Okay, that's finishing.